Good morning, everyone. Thanks for making it here. It's at 8 a.m., so I appreciate that. We'll probably wait 1 or 2 more minutes just in case someone's stuck getting coffee or something. In the meantime, I just wanted to point out that everything that we're going to be looking at today, all the material concepts, Jupyter Notebook, stuff like that, it's up there. It's at showyourwork.web.app. Now, certainly feel free to go through this, but if there's something specific that you want to look at in the next 1 minute that we have, I'd suggest looking at the setup instructions. They are not the easiest. Unfortunately, the material for this workshop is such that I couldn't work with the Nebari folks to help us get set up. So this is something that we'll all have to set up locally on our devices. There are like 4 steps, and installing Quarto, for example, may take like 5 minutes, and that's requirements are txt. That said, you don't have to set it up within the next hour. We are planning to take a break at 8:50, and or we'll take a break at 8:40, and we can use the next 15 odd minutes just to make sure that everything is set up. All right, I think it's time to get started. Am I audible? I don't know if the mic's on, but I hear some echo, so I believe that all of you can hear me. All right, perfect. The font's looking all good. If you have any questions, if stuff isn't working, if the screen gets disconnected, just feel free to raise your hand or shout out, and we can address that promptly. Okay, so this is the tutorial on showing your work. Off the top, I want to point out that this isn't about showing off your work, really, although that's one of the use cases of what we'll see today. And this is a tutorial on building and hosting web applications as Python developers. This is something that is very dear to me. As a data scientist, this is one topic that I think about a lot. And this is a culmination of a couple of years of my own work in building an open source library called Fastdash, which we'll look at in a little bit. As we get started, let me start with a little story. Oh, well, about me. I'm a data scientist at Lam Research. I'm based out of Portland, Oregon, which is a 3-hour drive from here. In fact, close to Portland. I work in Tualatin. And at Lam Research, we basically do semiconductor equipment manufacturing. I have a background in chemical engineering. I grew up in India, where I studied chemical engineering, moved to the US, got a master's degree in chemistry from Carnegie Mellon in Pittsburgh, Pennsylvania. And I've been doing data science at different companies over the past 5 to 6 years. And over these years, I've deployed more than 50 web applications. I believe it's a lot more than that if you count, some of these Hello World applications and stuff like that. And most of these obviously never find their way into the public domain because you build something for your company, and that's usually something that you cannot share publicly. But I spent some weekends working with friends, family, whoever else is interested in building web applications for simple use cases. Sometimes stuff that's really useless after the weekend, but I have fun that way. I also authored Fastdash, which we'll review in a little bit here. As part of my previous company, I worked for a water quality monitoring company called Ketos for a couple of years. Back in 2021, I was part of the team that won the first prize in the data visualization category, the mapping category. A couple of apps that I've built have also been showcased on the Plotly examples page. I checked a couple of days ago. One of the apps is no longer there, and that's on me. That's some maintenance that I was doing with my app, and I never really bothered to redeploy it. And as I mentioned, I'm a data scientist and Databricks certified as well. So here's a little story, and I believe this will resonate with all of you. Back in my first job, in fact, I was in Seattle back in 2019. I was handed a data set and a business use case, and I, do what all of us do: Python, Pandas, NumPy, stuff like that. Build a really nice report with all of my data visualization findings, put it all in a Jupyter notebook, as we all do, and then shared it with my team. My manager, a couple of my teammates, and product managers, and stuff like that. Create a team. Um, and one of my colleagues really liked it. He said, "Hey, Kedar, that's great analysis. Can you share the results with me?" I said, "Yeah, of course. Why not?" And I knew that, Jupyter Notebooks is something that not everyone uses. So I decided to export it in an HTML format, work done, shared it across with him. Then said, "Hey, can you add this one small additional analysis?" I said, "Yeah, of course, easy." Did that. Analysis v2 HTML, easy. Then he said, "Can you also modify this other part?" I said, "Yeah, why not? 5 minutes. All right, done." And this other thing, I said, "Yeah, why not?" And then before I knew it, I was here. I was feeling bad. I was miserable. Um, but fortunately, that was the end of it. Uh, Jump to my next project. I discovered that there's this thing called Jupyter widgets where you still are programming in Python inside Jupyter notebooks, but you have interaction. This looks very fancy, and yeah, I liked it. So I used Jupyter widgets in my next presentation. Same, showed a Jupyter notebook, and obviously the same colleague liked it again. But I learned my lesson this time. I knew that, I did not want to iterate a lot and just go through the same process. So I did this as a good teammate would do: educate them on installing Python, running Jupyter Notebook. I said, "Hey, install Python, install Jupyter, download it from here, add it to your path variables, create a virtual environment, install requirements.txt, add the virtual environment, your kernel, ensure that the data is at this location, launch Jupyter Lab, copy analysis, IPNB, click restart and run all." And this time he was miserable. But surprisingly, he did it, and he said, "But I use a Windows device." Oh crap! Never mind. That did not happen, but it could have happened. On the contrary, though, he said, "Hey, that's fantastic." 7 days later, he reached out to me. He said, "Hey, I ran the notebook and also learned a little bit of Python." That's fantastic. That's inspiring, right? When people go beyond what they're supposed to do, learn Python programming, and it's very inspiring. And now he had the ability to write Python as well in a Jupyter notebook. And soon enough, this is what ended up happening. Now he was writing notebooks, I was writing notebooks, and so on and so forth. Anyway, but that's what brings us here. That's one of the cases, one of the issues that we'll look at solving here in a little bit. Um, if we go back. So that's what this is about. This is about building applications really fast. This is not about building production dashboards with the best UI UX and the best security and like user authentication. This is not about that. And we'll discuss what I mean by that. We'll formalize all of those things here in a little bit. This is about taking an idea, turning it into a web application as fast as possible, deploying it as fast as possible so that you can iterate much faster. And if you're about to fail, fail much faster. That's what this is about. And then for those who were a couple of minutes late, all of this is at showyourwork.web.app. All the materials there. Feel free to follow along. There's also a few setup instructions out there. Okay, so here's the objective. Here's what we'll accomplish over the next 3 hours and 51 minutes. We will have built a few different, even if basic, web applications with your own data set. We will have created a personal app store, portfolio, gallery, call it what you want, where essentially users all over the internet, or maybe eventually your team at work, can visit, look at your apps, and play around with your ideas. We'll look at some ways of building and deploying these web applications. And then essentially you can take the source code and just go anywhere you want from there. You can modify it, change it, make it better, stuff like that. Specifically, the Python web frameworks that we'll look at will be these. We'll look at Jupyter widgets and voila. We look at Streamlit, Gradio, Fastdash, which is the one that I authored, and we'll also look at Quarto. And why these only and not some of the others? There's a simple answer. These are the ones that I've used a lot. There's also, a little bit of more nuance to it. It's not just my bias, which we'll review in a little bit as well. We look at Fastdash, why I thought of building it, what it does right now, and the ways in which you can use these concepts with your own favorite frameworks and try to replicate it, scale it, and stuff like that. Right. And here's the tentative schedule. We'll try to stick to this as much as possible. Let's spend 40 minutes on introduction, motivation, core concepts, as we've already begun. Um, the next 10 minutes, 8:40 to 8:50-ish, if you already haven't set up the requirements locally on your device, we'll go through that process. Setting up things locally is highly encouraged. Stuff like installing Quarto, although it's easy, that take a little while. Whereas installing requirements.txt in a virtual environment, that should be pretty straightforward. But I'm open to say Fastdash breaking in different environments. So let's spend 10 minutes doing that. Let's take a break for 10 minutes after. When we reconvene at 9, we'll set up Quarto, and not just set up, we'll deploy our initial application on Quarto Cloud. We'll spend the next few minutes, 35 minutes, looking at Jupyter widgets, voila, deploying a sample application if we have the time, followed by a break. At 10, we'll look at Streamlit and Gradio, followed by Fastdash. When we come back at 11, we'll look at more Fastdash. Hopefully, in the process of doing these things, we would have already built, say, 3-4 different applications, or maybe less, more, depending on how fast we move here. And then finally, we'll spend the final 40 minutes just deploying all the different applications that we built over these 4 hours, putting them into our app store and wrapping up. We won't probably need 40 minutes, but let's just have some buffer there. All right. So getting setup instructions are all here. If you want to just follow along as we discuss a few other things. If not, it's entirely okay to skip. All right. So we've discussed a few things. The scenario that I mentioned hopefully resonated with all of you. I want to point this out. Show Your Work is really inspired from Austin Kleon's book, Show Your Work. That's the title of the book. If you haven't read it, it's a nice, concise guide to putting your work out there in the digital world. And so that's where I borrowed the title from. And this is a really nice quote. I think it summarizes most of the things that we do. It says that if your work isn't online, it doesn't exist. And not that everything that we do must be online, but it should at least be indexed. It should be searchable by people who need to use the application that we are building. And we look at a few different examples of the way to do things. And a few things about web applications. When we say web applications for this tutorial, I'll mostly be talking about interactive dashboard-like applications, visual applications. Not so much the backend concepts. We won't be discussing building and deploying, say, REST APIs, so using Fast API, Flask, and stuff like that. Although most of the concepts that we discussed today, besides building dashboards, will be relevant to all of these other backend Python applications as well. But why do we need web applications to begin with? We already know that we can deploy web applications to speed up the process of communication. We can gain trust, we can fail faster, and we can share our ideas rapidly. It inspires more communication, confidence, and trust with our stakeholders, with, if you're looking for a job, with recruiters, hiring managers, just friends and family. It speeds up our projects, brings clarity of thought. People say that they sometimes write in order to gain clarity about some scientific concepts or other things that they're thinking about. I feel the same about building web applications. If you have an idea And if you can go quickly from idea to a prototype and just realize that stuff is working, isn't working, it just brings a lot of clarity of thought, and increases accessibility and adoption, helps you put your ideas out there, and helps people adapt to those ideas really fast. And again, as I mentioned, the focus of this tutorial will be on a specific category of web applications. And I call them research ready applications. These are not the production applications that hundreds of users will eventually use. These are mostly applications that will be deployed to your own cloud, say Google Cloud or your company's enterprise cloud with less than 50 users, more or less. That's what we're targeting. Um, and obviously, there are multiple levels to these web applications. There's what I call the level zero: exploratory scripts, Jupyter notebooks, maybe even PowerPoint documents. It takes usually hours to days to build these. Traditionally, has taken them, and it's just you who's using it, or maybe a couple of other people on your team, and not many other people. Like in the Jupyter Notebooks example, it was just me and that other guy who were using it, and then anyone else who had Jupyter and the right environment set up, but it's pretty limited. Then there's the level one web applications, hobby projects, where stuff that you do with your friends over the weekends. Takes a few weekends to build those things. And 5 to 10 people usually use it. This is for learning, sharing with friends and close colleagues. The level two is proof of concept. Has this is usually taken weeks to months to build, to make sure that you have the concept right, you understand the business case correctly, and the number of users is usually less than 50. And then we move on to the second tier, which is the internal production applications, so internal portals that we have at our enterprises. These take months to years to build, many features, many pages, many bugs, usually 50 to 500 different users. And then this public production, obviously, we won't even need to go there. Anything that is used by 500 people, 1,000 people, eventually millions of people and more. What we'll be discussing today, our target will be level 0 to level 2. We'll obviously look at Jupyter notebooks, and really quickly we'll cover level 0 that way. We'll look at hobby projects, level 1 as well. I believe my library, Fastash, and even Gradio and Streamlit to a huge extent falls under this category. And I don't mean that to undermine everything that they have built. Hobby doesn't mean that you only use it for hobby. It just means that we're not really using this for tens of users or hundreds of users eventually. And then level 2 proof of concept, that's what we'll review in a little bit as well. And we just discussed this, why do we need to focus on levels 0 to 2? One interesting aspect about building web applications that I've learned over the years is that there are really two common mistakes that people make. I've made tens of times. I either over-engineered my work, my applications, or under-engineered them. Let me give you a simple example. Where I work, sometimes the solutions are pretty straightforward. Sometimes the answer is C equals C plus B. And that's exactly what the business is looking for. And in such scenarios, I don't want to spend even a full hour on building a solution that doesn't really get us closer to the solution, or even if it does, I just spend 10 times more time as I should have on getting the actual solution in the first place. So that's over engineering. We certainly don't want to do that. And on the flip side, there's under engineering. That's, depending on your use case, you must deploy something for 50 plus users, 100 users. You need to have a set of fixed features in your application. And if you use the wrong tools, or if you just don't put enough work in building your application, if you just spend 10 minutes, for example, then you're essentially under engineering. You're not getting the value that you expect to get from that exercise. We'll look at a quick framework on how to think about these things as well, how to avoid over engineering versus under engineering, just based on a few of my experiences. Um, and yeah, if there's a few things, 3 things that I want you to take away by 12th day, just that work not seen is really work lost. It's just, your ideas. And that's completely fair if that's something that you don't want to share. Losing some work is not all that bad. But showing your work leads to more trust, confidence amongst your peers. It helps you to learn faster. And then finally, there are the process of building web applications and deploying is really templated. As long as you know what tools you want to pick, and as long as you know what template you want to follow, it's very reproducible. So if you've done something once or twice or thrice, the fourth time that you'll do it will probably take less than a few minutes, a tenth of the time that you spent initially in order to do it. Okay. Um, Here's a general view of building and deploying a web application. Or there are, I believe there are multiple ways in which we can think about approaching this problem, but here's just one way. We have a use case. It could be a use case at our work. It could be something that you're working with friends, or just all by yourself. But you always start with a use case. Depending on a single use case, you typically have a single app. That app you eventually end up deploying to a single server, or eventually maybe even multiple servers. But for the sake of this discussion, you deploy to one server. And by server, I mean either your local device or a remote server somewhere, or on-prem. And on the other hand, well, for another use case, you probably have a different application, and so on. You'll scale linearly with the number of use cases that you have. The maturity of these apps can be different. Again, as we discussed, we don't want to over-engineer, under-engineer stuff. All of these apps could be deployed all to the same server, depending on how the server is, how you want to scale and stuff. Or we could also deploy all of these apps on multiple servers eventually. On the other hand, each of these servers, they will, I'm assuming if they are exposed to the internet, they'll have an HTTPS or HTTP endpoint. And in some cases that looks very ugly. That certainly doesn't look like something that people can remember or expect them to have it bookmarked. So typically we have an app store, gallery, portfolio, call it what you want, that is also a web application in itself that's hosted on a separate server. I'm calling it server 4 for now. And it could be a static application, but really the way that we'll use this is to point to all of the other applications that we've built, so that people only have to remember appstore.com or a single URL, and that way they'll see a portfolio of all of the different applications. Once they visit it, they can click around, do the stuff that they're supposed to do. So the users really invoke the server for IP endpoint. They get to the App Store, and the App Store points them to the specific application that they're interested in visiting. That's the general flow. That's what we'll be exploring in a little bit. But specifically, here's how we'll adapt it. We'll still have the use case. We'll still have all of these applications. But the servers that we'll look at today will be one, Hugging Face Cloud, or Hugging Face Spaces to be specific, and optionally Google Cloud. Google Cloud is personally my favorite. I'll show you a way, and if someone wants to follow along, we can all deploy a few sample applications in Google Cloud. It's usually just once you have set up the Google Cloud SDK CLI on your device, it's just a single command away. Once you have the template, just write a single command, and it just throws your app onto the Google Cloud that anyone can visit. So these are the two servers that we'll consider right now. As far as the App Store is concerned, or the gallery, we'll use Quarto for that. I like the fact that it's very Markdown-like driven. And so if you can program, write Markdown, it's really easy to get Quarto set up and running. And we'll deploy this to Quarto Cloud, which is free. So it just works out for us right now. We'll deploy Quarto to Quarto Cloud. We'll deploy each of these apps separately to Hugging Face and optionally to Google Cloud. We'll configure Quarto Markdown in a way that it points to the URLs of these applications that we will have deployed. And by the end of this, I'm hoping that you can share. You'll have a URL that you can share with your friends or amongst ourselves, and we can really see what all of us have been up to. Let me take a quick pause here. Do we have any questions, any suggestions? Would you see things done any differently right now? Right, fantastic. Okay, so before we dive further into some of the technicalities of things, uh, here's usually how I think about building a web application. There are really three questions that we need to be answering. The first is the why, second is the what, and then the how. I prefer always starting with the why, precisely to avoid the challenge that we discussed in the beginning. We don't want to over engineer or under engineer at the same time. So it helps a lot to start with the why. And here, just some different whys that I have come across over uh, my few years of experience in this field. I have an idea sometimes, just want to share it with my friends, my community, with my team at work. And that's really why I'm building a web application. Or I just want to showcase what I can do, or really what my code can do. Something, a new algorithm that I wrote, a new model that I trained, um, new, physics-driven computation that I did. I just want to share it with my team, get their thoughts, shoot it down if they want to, but at least it's out there. Um, I also have been in situations where I just want to wireframe a new feature, share it with the UI UX experts, really get their thoughts, and get the ball rolling, and show off. This is a typo there. Uh, Show off my abilities on my website and resume. I've applied to a few different roles a couple of different times, and it has helped me if I were just to share a URL to a web application or my app store with a recruiter or the hiring manager, and they can really see what I've been up to. So that's the why. So we need to have a strong why before we begin. The second is the what. After we have a why, it helps if we know how we want to achieve it in the form of this what. So, for example, say my why was studying climate change or something and sharing something new that I found with my team. In which case, the what is the impact of rising global temperatures on drinking water quality, for example. That is a what, and then that leads to specific metrics, KPIs, and data sets that I need to look at. Another what could be if I'm applying jobs and stuff like that. Another what is my grasp of LLM concepts, for example. Um, Also, normally in work, we've had to track data quality, or if I'm working with the software team, the error rates and the number of bugs and deployments and stuff like that. All of that is a good what. The what should really translate into metrics and insights and KPIs. So we have the why, then we have the what, and then comes the how. The how is it governs what tool stack we want to use to build our web applications. Do we want to go with Streamlit? Do we want to go with React-based application? Do we want to stay in the Python domain, look at Plotly Dash or Gradio, something like that? That's the how. And there are 5 things that help us figure out that how. That's the first is what's the expected turnaround time. If people are really expecting us to have something deployed in the next 10 minutes, then the choice of tools that we use is entirely different than if they say that, hey, take a month and build this right. The other aspect to look at is what are the different UI components available with the tool that I'm using. That's the capability of the tool. There are some new tools that may not have as many different easy to use UI components as some of the other established ones like Dash and Streamlit. So that's an important consideration. Then there's answering how many users will eventually use my application. That's the scalability. If it's 500 users, then it's just a separate ball game than just 5 users or 10 users. How frequently will we alter the scope of the application? Um, some of these apps that we look at, they're very opinionated in a way that once you build it out, And if the scope changes, then just going back and altering a bunch of things is usually tricky. So it helps to know if the scope that you're considering, if how fixed that is, if it's flexible, or if it's set in stone right now. And then how will people access it? If if HTTPS public uh, URL is the only way for people to access it, if you want to restrict it to your team only, if you have, say, virtual private cloud, stuff like that, that where you want to deploy this, then the choice of tools may differ. So the why, the what, and the how. The why and what is not really something that we'll look at a lot today. That's very subjective. We'll certainly look at the how though. The how, I think, is very templated. We'll look at a few concepts, some of which we've already discussed. But as I mentioned, this is not rocket science. Once you've done this once or twice or thrice, doing it the fourth time is 10 times as easier than the first. So based on all of these different factors that we looked at, specifically the ease of deployment, capability, scalability, maintenance, and ease of deployment, um, this is an extremely subjective score metrics that I came up with. And I wish I could say that this is, well researched, and I went through 100 different research papers and spoke with 500 other different people, and this is an average of all of that survey. This isn't really. This is just me spending a few hours trying to think about my experiences using all of these different applications, conversing with my team, getting their thoughts, and just something that I put up together. And the way to read this is really column wise. So I listed all of these different web application frameworks that I've used. And then I thought about each of these different aspects hard. For example, development speed. In that, I literally just picked the one that I believe was the fastest at developing new applications, gave it a score of 10, and then worked my way back. In case of ties, I did not really use 10, just used 9 or a lower number. And here are the results. For development speed specifically, I believe the library that I built, I keep on saying this because I really want you to know that I may be a little biased towards my own library, but we'll find that out in the next 3 hours. It's probably the fastest out there in order to go from a new idea to prototype really fast. Followed by Jupyter widgets, all of us are used to it. Followed by Gradio, which is similar in concept to what I built because it's partly inspired from Gradio. Streamlit or Shiny, Streamlit and Shiny come fairly close. And then there's Plotly Dash, although it's really nice. I love Plotly Dash. Fast Dash is based on Plotly Dash, but you really have to know a little bit of CSS and JavaScript to get fancy things done with Plotly Dash, and that's why it gets a lower score. Similarly, UI components wise, Dash is amazing because there are many community members coming up with newer components and really easy to plug and play different components and aspects of the framework into Dash. So I gave it a score of 10. And because Fast Dash is based on Plotly Dash, Fast Dash can really use any component that Plotly Dash has. And so they get similar scores, followed by Jupyter widgets and Streamlit Gradio, and followed by Shiny, and so on. I wouldn't go through each of these numbers individually, but deployment-wise, I did not really see any major advantage to each of these things. Although I do want to point out that some frameworks like Streamlit and Gradio, or in fact even Shiny, and I think nowadays Dash as well, they have their own cloud infrastructure. So that way, if you build a Streamlit app, you could simply deploy it on Streamlit Cloud. I believe they have an enterprise version as well. I'm not too familiar with that. So does Gradio. Gradio has obviously really close collaboration with Hugging Face Spaces because they're really the same company, same team. So you could just change a single argument in your Gradio apps, which we'll look at in a little bit, and just deploy it to public cloud that for people to access. Um, I always found it a little difficult to deploy applications that I built with Voila. I had to struggle a little bit even a couple of days ago in order to do that. I gave it a lower score for that. But again, these scores don't really mean that Plotly Dash is the best web framework that's out there, or followed by fast dash. Although I would have liked that, but that's certainly not the case. The way to use this is based on your why, mainly the why, but also the what. You figure out which of these different things are important to you. If you want to get something up and running the next 5 minutes or the next 5 months, what kind of UI components you need to use. Do you need to have a chat interface with an LLM application, which all of these have these days, but a couple of months ago, or if like a year ago or so, not all of them did. Similarly, maintenance deployment, all of these are considerations that you need to score based on your why and the what. And give it a multiplier factor or something like that to each of these different criteria that we discussed, and that's how we really come up with the final score. Today, though, as I mentioned earlier, we'll look at Streamlit, we'll look at Gradio, we'll look at Voila, and we'll look at FastDash as well. We won't really look at Python Shiny, although there's a tutorial this afternoon on Shiny. If any of you is interested in attending, I'll be there, and hopefully, or let's see if that changes some of these scores that I've very subjectively given to Python Shiny. We'll see. Right. And then when we say we really want to deploy an app, what we're really doing is we're packaging our app code, the data, and the configuration into something. We'll look at what that something is. Once we package it up, send it to a server, could be a remote server or a local server, and then configure that application, really, run it, invoke the run script on that server so that we have an endpoint that people can access and use it to interact with our application. So that's what we really mean by deploying an application. Specifically, right now, we'll look at Docker for packaging and deployment. That's because Docker can handle different OS configurations and cross-platform deployment really well. That gives us consistency and isolation as well. We don't typically interact or impact some of the other components on our server or wherever we are hosting the application. So we'll look at Docker. We'll also review a few Docker concepts. But again, as I mentioned, it's also templated that even if you're not familiar with Docker, we should be fine today. We won't look at Docker any deeper than we will in the next 5 minutes. And here are the steps in deploying a Python app. We obviously start with local development, something that we discussed earlier. We build our app, start with our why, what, and how, build it in a Python script, Jupyter Notebook, or wherever. Test it locally, so that's all local development. Then we Dockerize it, convert it into a Docker image that we can containerize later. We typically version control, although this is not necessary, but if you're using Git or something else, it's a good practice to version control so that we push something from our laptop and then pull it on the remote server or vice versa. And then we simply deploy the app code, the packaged code onto the server. And hopefully that also means that server deployment also includes the part where you configure it such that everyone else can access it. And here's a few examples. Say you build your app. And this is a simple app that you can build and run even right now. So from FastDash, import FastDash, and you write your app function, define an app, and put it all in app.py. That's what you're really doing. Then we create a requirements file, as we always do. In this case, the only requirement is FastDash, and so you add that to requirements.txt. Then in the second step, we Dockerize the application. Again, this is all templated. I never remember these things. I just copy from a template that I already have. This is a Docker file that does a few things, but basically packages code, converts into a Docker image. It's a good practice to test it locally, although I'll admit that I don't do that as often as I should. And then the way that I notice that my application is missing dependencies is after I've deployed it to the server and I view the logs, or when people say that stuff isn't working, that's how I really figure out. Then there's version control with Git, GitHub, Bitbucket, GitLab. And the final step is deploying to the server. If it's a remote server or even local server, we SSH into that server. We won't need to do any of these things today. We'll simply leverage Hugging Face spaces in Google Cloud, and that way we don't really have to go through all of these steps. But typically, you SSH into the server, um, clone your repo, or if you've already a clone, you pull the latest changes, go inside your application directory, build the image, and then deploy the image as a container, and that's about it. As long as you have the right port pointed, it should simply deploy your application to the correct port, and you should simply be able to share it with the users for them to interact. And it's a good practice to check the container status as well. In case you're building your applications for production, it's important to consider security monitoring. We don't want to be in a situation where you know you follow these steps, deploy something to Hugging Face Spaces or Google Cloud with data that you're not really supposed to share outside your company. And so it's important to be aware of security aspects, and a good practice to keep monitoring. And this is how you update your application if you have new code, new features added. But yeah, those are the concepts. We will start writing some code here in a little bit. But here's what we have reviewed so far. We have seen that, well, first of all, it's really important to have a web application framework that you can use to deploy your ideas and share it with your team. But always start with the why, followed by the what, followed by the how. And the process of building a complete deployment pipeline really has 4 different steps. We build something locally, we Dockerize it using a template, we version control, and then we deploy it to the server. And that way, everyone can access it. Okay, so this is a good time to take a quick pause and make sure that we are all set up with all of these dependencies. By quick show of hands, how many of you were able to go through all of these steps and test things and make sure that it's working locally? All right, fantastic. That's nice. If you have any questions, feel free to ask me. If something's missing in the documentation, we can sort it out right now. For the rest of you, I would encourage you to start going through these steps line by line. All that we really need to do is install Quarto, which is right here. Depending on your OS, you should be able to install it, and then you should be able to invoke it from the command line, type Quarto version or something, and then you should see that's a good way to verify that you've installed this correctly. Again, Google Cloud CLI is optional. If that's something that you're interested in doing and want to follow along later, I encourage you to do this. Creating a Hugging Face account shouldn't be an issue, although I haven't done that for a while, so maybe things have changed since. And the tutorial files can be found on this GitHub repo. This is my repo, dkedar7.
Okay, first you'll have to unlock your device.
Did I say okay, Google? All right, sorry for that. Show your work, and then install dependencies, create a virtual environment, activate it, pip install requirements.txt. Install your kernel, because eventually we'll want this virtual environment to be accessible through the Jupyter notebook, and then simply type Jupyter Lab and you should be up and running. This is a good way to test out that things have installed well. This is only Fast Dash, but if Fast Dash is installed, I want to believe everything will have installed correctly as well. Okay, for those who are confident about your setup, why don't we take a 15 minutes break? We'll reconvene at 9. For those who are still working on setting it up, try spending 5 to 10 minutes followed by a quick break so that we can all reconvene at 9. How does that sound? All right, let's do that. Yes. Yes. All right. So how are we looking? All set up. I know that we have a couple of issues with Google Cloud, but was everyone able to install Quarto? Well, fantastic. Google Cloud CLI. How many people are still facing issues or want to deploy apps on Google Cloud today and are running into issues? Were you able to solve it? No, still open one and two. Okay, we'll come back to that in a little bit. Maybe there's something, some step that we're missing. Hugging Face account, everyone, awesome. And was everyone able to install this environment, get access to the files, and run a fast dash app? You all see that warning at the top when you run fast dash, and that's expected. So that's not an indication of wrong setup or something. That's something that we expect. All right. So with that done, let me. Oh, before we get there, something that I forgot showing you is, if you go back here, here's an example that I deployed of hopefully eventually what we'll all have set up in a little bit. Just some app gallery, which will look like this. So let me just refresh this to make sure this is the latest. Now we can change it however we want, but essentially this will be the gallery. And most of these are, except this final one, which is just added from some previous work that I did. In fact, with Power BI, it's a different world. Um, this is what we'll have eventually running for all of us. Okay, so that's it. Let's jump to the notebooks. And you should see all of this except this folder called App Gallery, which I added to my Git ignore. This is something that I set up locally, which we all will in a little bit. Um, let's open the third notebook, Quarto. And here's what we'll do. We'll spend the next 15 minutes just deploying an initial version of the App Store onto Quarto Cloud. And eventually, as we deploy additional applications, we'll just hook them on to Quarto and see it get updated live. Right. How many of you are familiar with Quarto or have used it before? Right. Awesome. If yeah, for those of us who have, and obviously for those who haven't, Quarto is built by POSIT, and then we know that they have a huge presence in SciPy. I haven't met anyone who works there yet, but I'm hoping to change that over the course of this week. It's an amazing tool. As I mentioned, it allows us to use Markdown-like language. They call it QMD to build web pages. How cool is that? When I wanted to build web pages 5 years ago, or longer than that, I had to learn HTML, CSS, JavaScript, but I no longer do. Even if it's just static website, Quarto allows us to do that. They really advertise Quarto as being, oriented for the scientific community, for reproducible research. You can build not just not just dashboard like or static web pages. You can build presentations inside Quarto, draft manuscripts, have some other interactions in the form of observable applications. So it's really amazing. Will most certainly only scratch the surface right now. We'll only use the leverage the part of Quarto that's relevant in order to build this. Um, and for that, why don't we do this? Why don't we? So now that we've already installed Quarto, we should all have the latest version. Um, I don't remember when I installed Quarto, so I have 1.7.32. Maybe if you did install it today, you have a newer one. Fantastic. All right. Here's what we'll do. We'll make a new folder. So if you run the next cell, it will just create a new folder called App Gallery in your local drive. And here's um, a handy Jupyter magic function that I typically use. For those of you who aren't familiar with percent write file, here's how this works. So as long as you define this magic in a Jupyter code cell, followed by some text file, everything that you write in that cell below that magic line automatically gets inserted in that text file. So this could be, test.txt, for example, and everything that I write under the first line in the same cell, and after I run it, that just gets written as plain text inside this file that we've defined. Obviously, we could have always just come in here and opened quarto.yml and copied stuff, but we're being a little lazy right now. So just run this, or if this doesn't work for whatever reason, just go inside app gallery, make a new text file underscore quarto.yaml, and paste all of this in there. And feel free to change the title to whatever you want. Now, what this really is, this is a recipe for how the Quarto website will look. That's what this YAML file's defining. The project type is website. We are not. This is not a book or a manuscript or a presentation. This is a website, and that's what the project type governs. Um, the title is this my web app gallery, but this can be anything. My teams, whatever, workplace or whatever. The nature of the web application, that the navigation that we'll be using is a nav bar on the left. It'll just have one page right now, which is index.qmd, and all this content that you see is a part of index.qmd, which we haven't written yet, which we'll write in the next cell. The title is home. Format is HTML, and I just chose a theme. But you can, if you go to the Quarto website, you'll see that you can customize this theme to your liking. And this is a very basic recipe for setting up a Quarto website. There are just too many fancy configurations that we can do to get this to look fancier and do other things that we wanted to do. But we are keeping it simple for now. Now, if you run the next cell, this will what will populate index.qmd, which is the home page, or rather the only page of our website right now. Some metadata of this page. This is the title. Again, feel free to change this as you want. The contents will be projects.yml, which is a separate file which we'll write in the next cell. This will be sorted by some metadata date, which we'll define eventually as well in the descending order. We want all the list of projects to be viewed not as a list but as a grid. So that's what this governs, and some other filter, and if you want to enable categories on the right hand side. So if I flip back real quick, so this you can just filter down by these tags. That's what categories does. We are using the full page layout in the article format. So that's what this is governing, the way that we want our index.qmd page to look. And then everything that's below this is marked down. You can change it however you want. This is some text that I've kept by default. This could be, stuff about you, your LinkedIn profile, your team's website, whatever else we want. And if you run this, it should create an index.qmd as well. And then the other thing that we need to do, I don't know why I have this advice to create a new folder called posts. Maybe you can ignore this or run this. This doesn't really do anything. Maybe I just forgot taking this cell out. But again, what we're doing is we're populating projects.yaml this time with a list of our projects. And the format that we'll use is the title of the project, which is a template that I have right now, the description of that project, free text description, followed by the URL of that project. And right now, feel free to leave blank all of these things because we haven't deployed anything yet. We don't have a URL yet. Another URL for the image, this can either be a local path. So I could have this image stored in a local folder assets and or something like that. And just instead of having a URL, I could have just pointed this variable to the local folder, the date, categories, and so on. Either use some placeholders for now, use exactly this as it is, or feel free to leave it blank. And then once this is done, if you hit the next cell, it will essentially render all of the QMD documents as HTML documents ready for static viewing. And once that's done, if you hit Quarto preview, and if Quarto is set up well, it will redirect you to a new URL on the browser, which will show you your web app. How many of us are there yet, or need additional assistance? We're there yet, right? No? Do you want some assistance? All right. And the final and I believe the coolest part that's yet to be done is publishing it to Quarto Pub or Quarto Cloud. Using this command, so you could either run this, copy this, and run this in inside terminal. That's what I would advise. So if I just opened a new tab, uh, went to my terminal, and I'm in my app gallery right now, as I'm supposed to be, and I just paste that command, Quarto publish, Quarto pub, and it's asking me, where I want to publish it to. Since I've already published this once, it remembered a few things. If you haven't published anything with Quarto yet, maybe it will ask you to create a new account, log in, create a new destination for this application, and maybe a few additional selections, and you should be all set after. Does it require you to create a new account or something? I remember it does, right? Right. How many of us are still working through this? Gotcha. It's been a while since I followed these steps, so I don't exactly remember how long it took me the first time around. Question? Looking good? Thumbs up? Question? Oh, God. All right. So now we have a portfolio, an app store that we've already deployed, and eventually, as I mentioned, we'll as we build more applications throughout the next couple of hours, what we'll essentially do is we'll go to publish or projects.yaml, and I have a few in here right now for the portfolio that I showed, but we'll eventually replace the title, the description for the new apps that we build. We'll replace the image. Again, this is optional if you have the patience to take a screenshot or attach something from the web, find a nice picture, photo. We could always attach it here, but if not, this is you could just leave this for now. Change the date, obviously, again not required. Categories is any other free form tag text that we want to apply. So for each application that we build and deploy in the next couple of hours, we'll modify all of these things, add a new section for the new app, modify these things, and essentially render Quarto again. And we'll go through this once we deploy the first app. Render the website again and publish it to Quarto Pub. That's basically it. Now we have our portfolio that's set up. All right. So now that we're set up with Quarto, let's try looking at what I believe is one of the simplest ways of deploying or building a web application. Now, we've been discussing web apps and all of these fancy tools, Streamlit, Gradio, and Dash, and for a while, but we did overlook the fact that probably the most accessible Pythonic web app is Jupyter Lab, Jupyter Notebook. We all use it almost every day. Um, and this is, as long as you have your colleagues who are used to looking at the Jupyter interface and don't mind interacting with notebooks and seeing a little bit of code and comments, Jupyter is probably the easiest way to build a web application. And that's exactly what we'll do here. So I won't go through or maybe we'll just quickly review this. In Jupyter, we have three different types of cells. We have what are called the code cells. That's where we write Python code or, R code, Julia code, stuff like that, but Python for now. There are markdown cells where we can write markdown and render it inline. And then there are raw cells, all the other text that we don't want rendered either in markdown or code at all. There's a Jupyter server and a kernel, but we are all set up and it's all running locally. You should have these Python libraries installed in your environment already. And here's what we'll do. The two objectives of going through this notebook are one, just to pick a data set for now. I have three sample data sets. If you go back to the root of this repo, I have three sample data sets. There's the car crashes.csv, there's the penguins.csv, both of which are publicly available. They are more or less well known. And there's a chlorophyll subset.csv. This is a data set that I generated for a different web application, but I thought it may give those of us who are interested in mapping things, putting coordinates on a map, a little bit of freedom to do that in the form of this data set. So I have three data sets right now, but certainly feel free to pick any other data set that you're interested in. If you already have something in mind, if not, if there's a data set that you like that's online, please feel free to use it. Somewhere down here, I have a URL of the repo where Seaborn stores its own data set. So if one of these is looking familiar to you, flights or Iris data set and so on, feel free to use it. But if not, there are three data sets that you already have in your repo. And we'll go through a little exercise in a moment. But real quickly before we do that, this is how the data sets look. So if I run this real quick, this is the famous penguins data set, different species of penguins where they're found, some of their features, and if they're male or female or unknown, all of that's here. Similarly, we have the car crashes data set. This is all of the car crashes over, I don't remember how many years, but all of this information is here. Um, these are traffic accidents, number of crashes, injuries, fatalities by state or region, and blah, blah, blah. So, that data set is available. One thing to note is that most of these columns, but one, all of these but one, are numerical columns, which has its own benefits. And the final column, the abbrev column, which is the abbreviation of US states. So that allows us to do two things: categorical analysis, and then also put it on a map. And then the final data set is the chlorophyll concentration analysis data set. This is a data set that is generated using the Landsat data, which is satellite data. It's coordinate based. So we have all inland water bodies in New York State. We have their ID. We have their coordinates, their longitude and latitude. We have the date on which we acquired uh, those images, and the predictions for the value of chlorophyll at that particular point. So that's what we have, and this is how the data looks. Again, allows us to do some mapping if someone's interested. There are also numerical columns and categorical columns in the name of, in the form of the lake, the name of the lakes, or you could use any other data set that you have in mind. So let's do this. In the next 15 minutes, let's go through this exercise. First of all, pick a data set. That's the first objective. And then once you've picked a data set, so say you pick the penguins data set, which is probably the easiest. And if you ask me for suggestion, I'd probably suggest you go with that right now. And then I have here a set of 5 different prompts for each of these data sets that you can use to create a few different visuals. And that's the second objective of this notebook. Our objective is to create a few visuals, use Matplotlib, Seaborn, Plotly, and try to answer these questions so that we can use these visuals for all of our applications eventually. So when we build some applications with eventually IPy widgets or Gradio, Streamlit, FastHash, we won't have to rebuild any of these visuals. We would have them handy. We could just reuse them eventually. And let me check in with you by 9:40. Uh, and let's spend a few minutes discussing IPy widgets and voila after that. Um, and as you go through this, I want you to remember that the goal of this tutorial is not data visualization. And am I using that as an excuse to make really sloppy visuals? Maybe I am. But since the intent is not data visualization, there's another notebook, 4.1, data visualization suggestions, which basically answers all of these questions. So if you don't want to write any code, or if you something that you've already written done before, just feel free to grab some of these visuals from here and put them, or just run this notebook. So let me check back with you in 10 minutes. And as you make these visuals, maybe just one final point, I don't mean to interrupt you guys, that I'll keep in mind is eventually, most of these are static, more or less, right now. We are not changing any variables. We are not adding any interactions just yet. But as you write your code or maybe reuse some of this, keep in mind that eventually when we look at interactive web applications, Gradio and stuff like that, we will add some interactions. We'll add sliders, we'll add drop downs, we'll add text input, we'll have dragging, all of that. So as you're building this, even if you don't explicitly use that in your coding right now, but if you can keep in mind that eventually we are planning to add interaction, maybe that will govern some of your programming decisions right now. But how are we doing? Do we feel like we need a few more minutes? I know that I said 15 minutes, but it's only been 10 minutes. Just wanted to gauge. Right, let's do a few more minutes. Okay, it looks like we all have something decent. We just two or three visuals charts for now to get us started. Okay, so with that, let's check out what Voila is. Uh, Now, I had a little bit of trouble working with Voila in the beginning. It's certainly not this. Then, the moment that I started saying the word Voila out loud, every time you deploy Voila Jupyter Notebook, simply works. You should try it. All right, but no, Voila is amazing, and the reason is because I said in the beginning that probably one of the most or the most accessible Pythonic web application out there is Jupyter Notebook, and Voila is a way of taking that Jupyter Notebook and then deploying it as a web application to an endpoint while retaining all of the interactions. If you have Plotly like JavaScript static interactions, those are retained, but also eventually, as we'll look at Jupyter widgets or IPy widgets. All of those interactions are widget as well. So Voila essentially spins up a Jupyter server and then deploys your Jupyter notebook on that server, and also gives a nice Jupyter-like UI still to be able to maintain all of those interactions. Now, again, we'll with Voila as well. We'll just barely scratch the surface. We'll simply use a single command, which is you all must have Voila installed in your environments already. So all that we really need to do is type in Voila, which is the command, followed by the path to the Jupyter notebook. And let me show you how that works. So let me go back to my terminal. Let me go to where I have all of these notebooks. All of those notebooks are right here. And let's deploy this, 041 data visualizations notebook that I have as a web app. So 4.1, of course, I don't have my environment activated. We activate, surely work, right? And there we go. In just a matter of a few seconds, we will have the same Jupyter notebook with the code hidden, but everything else is rewritten. All of this is marked down. This, as you may remember, is the output of pandas.head. So this is code execution result, just retained as a table, and also the visuals that we added a few moments ago. All of those are right here, exactly as we saw them a moment ago. Now, I certainly have many more visuals than you may have at this point because these are about 15 different code execution results. But the point is, now we have an app that's deployed to localhost, my local server, port 8866 by default. And this is the Jupyter Notebook. And our goal will be to just take this application, put it in Hugging Face spaces, or Google Cloud in a way that everyone else can access. That's our intent. Now, you may have noticed that we're not using any additional configuration, no other fancy arguments that Voila has, and it certainly has a few. So we're just using all of the default versions. That means that we don't have any theme to our notebook. We don't we have hidden all of the code cells as well. We don't have any navigation bar or anything else that will help the user go through this application. But I encourage you to check this out whenever you have a few minutes later and see how best you can use this with some of your use cases that we have. But for a simple Jupyter notebook like execution, this just works fine. Now let's do this. Let's quickly review IPy widgets or Jupyter widgets, and we'll still use Voila, but as against using it on the static visuals notebook that we had, we'll use it with the Jupyter widgets notebook in just a few minutes here. What are IPy widgets? The definition of widgets I recently found in the Jupyter space is a little nuanced. It's not simply a UI component that allows you to interact with it. That's something to do with uh, two-way communication. If one of you knows better about it, please feel free to jump in. But as far as we are concerned, widgets are interactive UI components that allow us to either feed in a value using a visual selection into the Jupyter notebook or read a value back as the output of our code execution. That's what we mean by widgets in this context. And IPy widgets are a way to add these visual elements to Jupyter notebooks. And here's what they allow us to do. And there are, again, a bunch of different widget types that we can use. Some of the most common and the simplest ones are, say, the slider visual, the slider widget, where you define a widget such as this widgets dot integer slider. That's the one that I'm using right now with a default value of 50, minimum value of 0, and I want it to go as high as 100 in this case. And then I simply display that slider, and here's how it looks. But the biggest benefit is that now, say if I set it to 73 or whatever, I don't have to do anything else to get that value out from the widget. And it's all updated automatically. So what I mean by that is, as long as I have a slider object defined by the keyword slider, and if anywhere else in my code I just do slider.value, I just simply get that value. If I set this to a different number, 23, and I run this again, I get that value 23. So what this means is, now imagine if we have a function that takes in slider.value as its input. Now we can simply change the value of the slider, run that function, and that could be any complicated or simple Python code, and we can interactively feed our inputs into the function. That's the value. And there are a few other drop downs, few other widgets. There's a drop down widget just widgets.drop down, pretty self-explanatory. It's option 1, option 2, option 3 for now, just something that I copied from the documentation. It's the button visual, and this is a little interesting in this case. We define the button visual. There are a few optional components. We define them nonetheless. We want it to show the text "click me" with button style success. That's what gives it the green color. We also define an outputs component. This is where we'll capture all the outputs here in a little bit. But more interestingly, we also defined a new function that allows us to define how the interaction with this button will do. And here's what it means. So on button clicked, it simply takes some argument, and then by using the output area that we define, it simply prints button clicked in that output area. That's everything that this is doing. A quick note about this: we may not always have to use this. This is essential when we must define some additional interaction that goes beyond the Python function that we are about to define in a little bit. But I just wanted to show you that here's an option. We can define a button widget, and then we can define what we want to happen once someone clicks it. Right? And then in this case, if I click it, it will, it has already defined an output area, and it should just print button clicked into that area. But here's something interesting. If I don't have an output, not that I always should, it should still print this somewhere, and it will work that same way. But instead, you'll see that the blue icon there is going a little berserk, and that's because it is returning button click, but it's going in my Jupyter logs right now. And because we don't want it to go there and instead be displayed here in line, that's why we need to define an output component and then explicitly say that, hey, use this output component to do this. And then this could be, matplotlib plot, cbon, plotly, anything else, pandas, data frames, and we could all just display those components here, and they'll get shown once we click this button. That's what's really happening here. There's the text input widget, obviously. Just say hi, and then, oops, and then, if I do, as we saw a little while ago, if I do dot value, I just get the value. This could be anything. As long as put it there, I always get it back. So those are widgets, and then we'll look at a few additional examples of widget. I think I've put a link at the bottom of this notebook. But here's an example of how to use this widget along with any custom Python function that we have. So I just picked, again, some function from one of their examples to plot a sine wave. It takes 3 arguments: the frequency, amplitude, and phase. And then depending on these 3 arguments, we plot a sine wave using matplotlib that has a specific frequency, a specific amplitude, and a specific phase. And all of that really goes in here. X remains the same, but the Y values change, which means the nature of the sine wave changes based on these 3 things. Now the problem statement is, I want to plot this chart in a way that users can simply use widgets in order to change these input arguments and be able to view the updated plot. That's the challenge. And the way to do that, as we saw, is first we define 3 separate widgets for each of these input arguments. So we have the frequency slider, which is a float slider widget with a default value of 1, but minimum of 0.1 and 5. It increments in steps of 0.1 and description that gets shown as text in front of the widget. Similarly, I have the amplitude slider, which with similar arguments goes max of 3. And then I have the phase slider, the default value 0 goes from 0 to 2 pi in steps of 0.1. And more interestingly, what I want to do now is after I've defined these visuals, I want any changes to these visuals to impact my Python function, which is plot sine wave in this case. And the way to do that is using the interact method of IPyWidgets. I simply use widgets.interact, give it the function, which is this, that's the one that I want to manipulate, and followed by the arguments and the components that I want to use for those arguments. So plot sine wave has three inputs. It has frequency, amplitude, and phase, three arguments. Um, and for frequency, I wanted to use the frequency slider component that I've defined. For amplitude, I wanted to use the amp slider component I've defined. And for phase, the phase slider component. And this widgets.interact simply ties these things, the custom widgets that we have defined, to each of the input arguments of our Python function. So if I run this, it uses the default values. But now, more interestingly, when I change each of these values, the function gets updated based on the value that we've selected and the widget interaction with each of these inputs, and I get the updated chart back. And so this cell right here, this is probably, again, as I mentioned, most of these things are templated, but this is how we typically interact with all of the functions that we'll write. I haven't seen many cases where we need to have buttons, and so we need to have defined the interaction with buttons, as we saw a little while ago. But in case you have a huge data set and you only want the function to run after you change all of these arguments at the click of the button, that's when buttons really come in handy. But for smaller data sets like the one that we are dealing with right now, we don't really need to have a button at all. And so step one, we define the function. Step two, we define each widgets that we want to use to manipulate the function inputs. And step three, we simply use widgets.interact, give it the function along with each of these inputs, the widgets that we have defined, and simply run the cell, and this is what we get. And eventually, as we'll see in a little bit, once we deploy this with Voila, the default values govern that. The code gets hidden, so the users only see this, and that's exactly what we want. And I have a few additional examples here, but they more or less do the same thing. This is another function that has three inputs to it, a sample pandas data frame that's been defined, and it outputs another matplotlib chart. That's the first thing to do. We define the function. The second step is we define all of these widgets that we want to use to manipulate that function. And in the third step, we simply use widgets.interact and give it the function along with each widget for each input. And if we run this, that's what we get. For each of these categories, category A, B, and C, I have my interaction defined. That's basically it. Now, there's an exercise as well. And the exercise in this case is to pick you've already chosen a data set, but to open the cell for the data set that you've chosen and add a few interactions. So say if you choose the penguins data set, but how many of us choose the penguins data set by quick show of hands? All right, great. And how about car crashes? Okay. And the chlorophyll data set? Gotcha, great. So I guess most people choose penguins data set. But let's try to go through this. Let's add a drop-down menu so that users can choose between a few of these different categories, column names. So we have the species, islands, and the sex column in the penguins data set. So we just try adding a drop-down that looks like, we had the categorical drop-down somewhere, didn't we? That looks like this, which has three options right now, which is the choice between these three columns, and use one of the visuals that we defined earlier, put it in a Python function, and see if you can use widgets to interact with it. And I have three different prompts here, but feel free to use just any one of these that makes sense to you, or if you have a few more minutes, feel free to use all of these. Similarly, I have one for the car crashes dataset and a set of prompts for the chlorophyll dataset as well. right, how are we doing? Any questions? Were we able to get one interaction, the iPad widget set up? Great. And so let's do this now. We're running a few minutes behind, but take a break in about 5 minutes. In the meantime, let's do this. Let's do a couple of things. In fact, let's run the widgets notebook that either you have written, the one that you've written, or the one that I already have. Well, I do not, but just the basic notebook is the one that I have. Let's host it locally for now, and then in the next 5 minutes ish, we'll try to deploy this on Hugging Face Spaces the way it is, and it doesn't have to be perfect, obviously, for now, given we are a little time constrained. But let's do that together. So for now, here's what I'll do. Just the way that I deployed the static notebook, I will use Voila on the widgets notebook that I have, and just like that, it's all deployed. Again, the code cells are hidden by default, and all of the components are retained, and um, you know all the interactions are preserved as well. This is ready for deployment. One quick thing that I wanted to point out is that I learned from Juan a little while ago here that there's this new to me, new service called Voicey, um, that essentially renders the Jupyter widgets and Jupyter code as a static web page. So that way, if you have, say, tens of people, hundreds of people visiting the same page, they don't have to be bottlenecked because of Jupyter server dependence. And so, since this renders Jupyter notebooks as static pages, it scales really well. That's really what I understood. Okay, thank you. No, I didn't know. So it's really good to know. Okay, so that said, we have something that's running locally, obviously, and let's do this now. Let's go to Hugging Face Spaces. Let's create a new space. If you've already created an account, you can just point your browser to huggingface.co/new hyphen space. That will take you to this. Let's give it some space name. Voila SciPy demo, for example, in my case. So that, as soon as I do that, feel free to skip short description, license, and so on. Uh, the template that we will use for now will be the Docker template, since as we discussed a little while ago, we are using the Docker way of deploying apps. And right away you'll see that the moment that I click Docker, there are a few services that show up, and a few noteworthy mentions here are Streamlit, Jupyter Lab, stuff that we're used to seeing. Um, there's also Shiny Python, which we are not looking at right now, but Panel's pretty well known. Marimo is coming up real quick, but doesn't have Voila yet. So we'll use the blank template for now. So just click blank by default, and it'll just choose all of these settings and just create space for now. And once that's done, they'll show that this is how I'm supposed to clone the repo. So I'll just copy this, Command C. I come back here and maybe I'll make a new folder that I already have this is app gallery. I have a deploy templates, which you should have as well. Here's what we are about to do. I encourage you to create a new folder wherever on your local machine, and maybe I can do that with you. So say in the notebooks folder, I create a new folder, let's call it apps, for example. And if I cd inside apps, it'll obviously be a blank folder, but I will clone the repo that we just created in Hugging Face Spaces in here, just so that there's a nice isolation of, all of the places where we're cloning Git repos and building our apps. And if I cd inside that repo, it'll be more or less blank right now, besides some of these basic Git things that are there. Now, next challenge will be to transfer our Jupyter notebook in here, which is straightforward. But one of the other challenges that we'll quickly run into is defining a Docker file uh, so that we're able to deploy these Voila applications. And although we won't look into how Docker files are written and what the recipe is, I was able to find this Docker file on a Voila repo where they taught people how to deploy Voila apps to Hugging Face spaces, and I've basically just reused that. I made a couple of changes for requirements.txt, but as I said, the deployment process is basically all templated, and we don't need to worry a lot about what this is doing right now. So here's what I'll do. I'll just simply copy the Docker file, the requirements.txt, and voila.json from here, go back to my apps directory and into the repo, and simply paste it there. So the Hugging Face repo that we just cloned should now have 3 additional files. So if I do git status, we'll show that I have 3 additional files in my git. The next thing to do will be to copy over the notebook that we are interested in deploying. So in our case, that's Jupyter widgets, or if you want, you could just deploy the static notebook as well, or any of these other notebooks, doesn't matter. So I'll copy this, come back to apps, come back here, paste this here. And once that's done, and if you open Docker file, the one that we just copied over to the destination folder, you'll see that the final line is how we tell Voila what notebook we want to deploy. Now this can also be a folder, in all honesty, with multiple Jupyter notebooks. But in our case, it's just a single notebook that we are deploying for now. Incidentally, I had the same notebook already mentioned in the Docker file template that I uploaded. So as long as you're copying the same notebook, you wouldn't have to change anything. But if you're copying a different notebook, we'll simply have to change the file label, the file name of that new notebook. And once that's done, we just use git to add all of the changes that we made, commit it back to the repo, something like that, and push these changes back to Hugging Face spaces. And as soon as I do that, if I come back here, you'll see that Hugging Face is aware that I made a few changes, a few commits, and push something. So it's building my application in the backend for me. And that's about it. So what we did so far, if I have to quickly recap, we had a Jupyter notebook that we drafted. We defined 3 additional files we created a Hugging Face repo. We cloned it locally. Along with the notebook, we added 3 additional files to that repo. We added a Docker file, which is basically a templated. We added a requirements.txt, which should have all the key requirements that we're using. But if you're using a different library, you will have to add it to requirements.txt. Voila.json is static. These are all Voila configurations for Hugging Face. A very simple JSON that looks like this, the IP and port, and so on. And the only change in that case that we'll have to make is to change the name, the label of the file that we are interested in deploying. And once that's done, we just push these changes back to the Hugging Face repo. Hugging Face is building the app for us, and in a few minutes, we should get that same notebook deployed to Hugging Face, and we can literally share that URL with everyone else so they can interact with it as well. Any questions so far? I know that we rushed through the Voila Hugging Face deployment. If you have any questions, if not now, anytime later, feel free to talk to me. That was inside that same repo that we cloned this morning. But if you go inside deploy templates and voila, that's where you'll see all of these. Yeah. Right, so it's 10:10 right now. Why don't we take a 10-minute break and we can come back at 10:20. And in the meantime, or even after, if you have any issues with setting up Hugging Face and deploying this application, let me know. But if not, we can then hop on over to reviewing some Streamlit and Gradio and essentially following the same process with those tools. here's what I'm doing. I'm just, we are in a break right now, so feel free to get some coffee and walk around. But I'm just going through the steps of deploying a sample Jupyter notebook on Hugging Face basis. Again, if someone's interested in following along, let me close everything else. It's distracting. Right, so I'm somewhere on my device. I'm in notebooks right now, and is that a question? Oh yes, better. I'm somewhere on my device. Doesn't really matter, but you know, I'm in my. This is. Let me go to the root folder of my repo, right, where I have all of these, assets and description.md license and so on and so forth. Right, we haven't done anything on Hugging Face yet. Let me create a new folder here. Let's call it, demo apps, for example. Right, so that's right here. So let me cd into demo apps now. Here's where we'll eventually have a separate directory for each different app that we deploy. But as the first line of business for the Voila deployment, we'll just start with creating a new space. Come back here. Let's call it Voila SciPy 2 in this case. Could be any name really, doesn't really matter. We'll skip all of the default steps, select Docker, blank is selected by default. I'll select everything else, keep everything else default, public repo, yes, and then simply create space. I know that a couple of you had issues at this step because the account was pending authentication, and I hope that's resolved now. Great. And the moment I do this, I see this git clone command right here, which should allow me to clone this repo locally. So I can just select this, git clone, copy this, come back here, and I'm still in my demo apps directory, and I'll just clone this repo, and I have that repo with me here locally. Now if I cd into it, it will be basically blank, but all of these default files that Hugging Face created for me. But here's what I want to do. Before I push any changes back, I want to make sure that this folder has the right Jupyter notebook. It has the correct Docker file recipe, and it has the requirements and the Voila JSON file that's required for Voila deployment. And to do that, I can either CP and move the correct files into this, or since I'm using Jupyter Lab anyway, I can go into deploy templates, Voila, which is where I've stored all of the sample template files anyway. So just select Docker file, requirements, voila.json, copy these, and bring it back to where I cloned my repo, which is inside demo apps, Voila SciPy 2. Just paste this back here. And then, obviously, those files are getting reflected right here. We have the Docker file, requirements txt, Voila JSON. And since this is a Git repo, if I do git status, it will show that there are three files that had changes. Basically, these are all brand new files, so that's something that we expect. And finally, now that I have the template set up, the only thing that I have to do is find a notebook that I want to deploy. I can either obviously create a new notebook inside this, or better yet, we can just reuse one of the notebooks that we've already created. And since I've already deployed the Jupyter Widgets notebook, maybe just deploy this data visualizations notebook this time. So I just copied this. I will bring it back into my Voila SciPy 2 repo, put it out here, and that's it. My repo is all set up for deployment now. Well, sorry, I take that back, not yet. In my Docker file, I just have to modify this file pointer. So that's the way that when I push this back to Hugging Face, it knows what it's supposed to deploy. So I'll just copy this label, and edit it inline, right? So my Docker file setup. If I quickly open this notebook, I just want to make sure that I have all the requirements all mentioned. So I have pandas, which is inside this requirements of txt. Let's just compare pandas, matplotlib, seaborn, plotlib, and that's really everything that I use throughout this notebook. Right. So it looks like my requirements is all buttoned up. So I'll go back to the terminal now, and I just need to push these changes back to the Hugging Face repo. For that, I'll add all of these new files that we just modified, commit these changes, and call it new files something. So these changes are committed locally, and I just need to push these back to Hugging Face by git push. Right, and then Hugging Face knows that we have done something, and it's trying to build this app for us from scratch. And hopefully, if everything is configured correctly, this will end up showing that notebook on Hugging Face spaces and not just locally. And you must have noticed that it takes a few minutes for it to deploy completely, especially during the first deployment. So while this is happening, let me go back to this one, which is the one that we deployed a few minutes ago, the 606 widgets demo notebook. And this outlook, so we have all of these widgets showing up. We have all of these drop downs and interactions preserved. Except this, I guess. That's strange. I don't know why this isn't updating. And then we have the widgets.interact interaction setup as well. Oh, certainly. Yeah, this we don't expect this to update anyway. That's because this is a static text as far as the Jupyter notebook's concerned. So we're not adding any interaction to this text, so it won't update. But we are adding interaction with in the form of these visuals here, these widgets and the plot. Right. The rest of it seems to be working well. We'll just wait for this to get deployed, which again will be a few minutes, and we'll be all set. I was missing a module there. I missed adding Seaborn, which is, as I mentioned earlier, this is my way of figuring out what's missing, but not the ideal, of course. So just come back here to requirements, add Seaborn, git add, commit, push. Right, and we are also back from the break. The only thing that's remaining is just right click push. That's it. I don't know how many of you noticed, but I missed another dependency in this case, which was I forgot uploading my data, moving it to my repo, which Sucking faces no way of accessing this. And as soon as I do that, this should work. But if not, the app's deployed, it just isn't working because it cannot find the penguins.csv file. But yeah, I wouldn't bother about that right now. Here's what we'll do. I'll quickly go through these steps just one more time within, in say 45 seconds to 1 minute ish, so that we are all on the same page. And then we can move on to Streamlit and Gradio. Right. So here's what I did. I began with making a local folder. Then I created a new space on Hugging Face, cloned it, and here's what I have. This is the result of the clone, voila, SciPy 2. Um, into this, I moved a few different files. I moved the Docker file from the templates folder, which is inside. So if I go to my root of the repo and notebooks, deploy templates, it's right there, voila. And I copied Docker file, requirements txt, and voila JSON back to where I have this voila SciPy 2, which is in my case right here. So I have the Docker file, requirements, voila, right there. And then I also move the notebook which I want to deploy into the same folder along with all of these other files. And then finally, just making sure that we have all of the dependencies set up, and we have the deploy command pointed to the right Jupyter notebook. And once that's done, we just git add, git commit, and git push back to Hugging Face, and that should deploy the app. Right. So that's the general process. We'll follow more or less the same process for Gradio and Streamlit as well. Although for Streamlit, this process is significantly easier, follows a different template, and that's because if I go back to a new space and eventually if I create a Streamlit SciPy demo space, I'll leave these for blank. As we saw a little while ago, once I click on Docker, it already has a template for Streamlit all set up for us. And so eventually, once we build a Streamlit app, we'll simply select this, create space, which I'll do right now just because we don't want to wait a few minutes after. So just I'm creating a demo Streamlit space, which I will clone in a little bit and modify the files and push it again. But just so I save a few minutes later, I'm creating a new space, Streamlit right now. So just selected Hugging Face spaces, new space, clicked on the Docker templates, selected Streamlit as the template, and just created this space. And that's what it's doing. It's deploying a demo app for me right now, which eventually I'll clone and modify. All right. So let's move on to the new set of notebooks, which are, let me X everything out. Again, quick show of hands. I know I spoke with a few people who have used Streamlit before, but anyone else who's used Streamlit before at a high level? We're fantastic. We are scratching the surface here. We're not looking at any advanced stuff just yet. Um, Streamlit takes a slightly different approach than Voila, and maybe if you've used other web app frameworks, you'll see that it's nice and convenient in a way where you just usually define a single Python script, and as long as you're using normal Jupyter Lab stuff like print statements and display statements, Streamlit simply picks those up and shows those components in the appropriate places. And we'll see in a little bit what I mean by that. The import is this, import Streamlit as ST. Some of the other dependencies are the ones that we have been looking at all along. To deploy, to store the files for our Streamlit app, we'll just create a new folder, call it Streamlit. Change directories to that so that all the files that we write eventually as a part of this notebook get it in that directory and not anywhere else. And let's look at a few basic Streamlit components. And all of this is available on Streamlit documentation. And there's a lot more stuff to be learned from that documentation as well. A simple app looks like this. And again, I'm using the write file magic function followed by the text file label as well, so that everything that follows this first line ends up in basic app.py. I import the Streamlit module as ST, and then I use a few convenience functions, convenience methods such as this. st.title, for example, gives a markdown like header one title to my app. And this is my first Streamlit app. Could be anything. Let's in fact run this as we go. Let me do this, hit that. There's also a header component that we can add, and we'll see how this looks in practice in a little bit. There's a subheader. There's some text that we can add. Uh, there's also markdown component. A lot of different stuff for adding text and numbers and data types. So if I run this, this app is written inside basic app.py. So now if I go to my terminal and cd into Streamlit, because that's where we have that app. Now to host Streamlit locally, to deploy it locally, the command that they recommend is Streamlit run followed by the Python script where we've written the Streamlit app. If you simply hit enter, just make sure that you have the right environment set up. Vact says show you work. Vact is just some shortcut that I have set up to enable environments. Right, there you go. That's our simple Streamlit app. That's the title component. That's the header. It's the subheader and all other text that follows. You can simply use the write method to write any text, add numbers and other complicated data types as well. So that's the basic app, and the script looks like this. This is exactly what we modified in the Jupyter notebook. The title gives the larger markdown header one title, as we discussed. The header gives a slightly smaller text than that. There's a subheader, and everything else can just be printed on the screen exactly the way that we see this right here. And now we can add, there's some other fancier ways of writing text in Streamlit as well. We'll skip through this. But what we're interested in seeing essentially is adding interactions through our charts. And that's by using components and widgets as well. So what we're really more interested in doing is adding input and output components. Input mainly, we've already seen the output. And how that can be used to interact with our applications. And an example of that is, so these are some ways of plotting data sets in Jupyter using Streamlit. And here's an example of the input widgets. So again, we're writing this app to widgets.demo.py. We have the title and the header as we had before. But here's an example of some input. And we're doing that by using the text input method, text input component. And the arguments simply go like this. For text input, it's the question, what we want to be shown as the prompt, so users can enter their answer into it, and a default value. There are a few other arguments, all of them are optional, that go into it, which we'll quickly review in a little bit. But that the output of this component, when we say something like this, line 13, that's stored in the variable called name. Very easy, variable equals the widget as you define it, so that when people run that app, the input that they put in through the widget gets stored in that variable. That's simple. And then we can use this variable as text everywhere else through our app. And this applies not just to text, but to number inputs as well. So we have st.input number, asking a question, how old are you? Expecting an integer as a response. And that, in this case, as soon as someone types in something, the default value is 25. But as soon as they edit it, it becomes, it takes the variable age takes that new value, which you can use through the rest of your code as well. Temperature as a slider component. Then we have select box, which is Streamlit's way of referring to dropdowns. We have multi-select dropdowns. The radio button components, checkboxes, and date inputs, and time inputs. And this is probably already a lot more than we need right now. So let's run this. Let's write this to a file. And it looks like this, which is demo. And then to run this, we'll come back to this, write streamlit run followed by the Python script, which is widgets.demo.py. And that's it. That's all of our input widget components. So it's the name, which is something by default. The age value is here. We can obviously edit this. That's temperature in Celsius, I hope. And it's also getting printed, by the way. If you remember, we had a little print statement right below each of these input components, and that's how we are able to see these outputs as well. And all of these. So this is an example of a single select dropdown or a select box that allows us to select a single option at a time. There's also multiple selection option in the form of the multi-select dropdown that's available to us. There's the radio buttons, checkboxes, date inputs, time inputs. If someone's interested in intervals of 15 minutes, and another component that allows us to upload files that we can eventually use in our analysis as needed. Right, so that's Streamlit in a nutshell. Now we have a couple of options from here. We're running a little behind, so we can either go through the same exercise that we did of porting the static widgets that we already ported Jupyter widgets, but this time in Streamlit, or we can skip it. So what I think is, let's revisit the deploy process for Streamlit one more time. I'll probably just deploy a sample app, and so that we all can see it's the same process that we used for Voila as well. And then after the tutorial, please feel free to modify it with your own data set, plug things in, and try deploying it to Hugging Face spaces. And if you're unsuccessful, I'm here for the full week. So let's do this. The final script that we wrote, which is widgets demo, looks like the most interesting one because it has a lot of different input and output widgets. And then you'll remember that as we began, we selected a default Streamlit space. We created it, and here's how it looks. This is none of this is what we did. This is just the default demo code that Hugging Face had for Streamlit deployments on their website. But here's what we will do. We'll clone this repo locally using this command. So let me come back to my terminal, exit this. Let me come back to notebooks, and I made a new folder called apps in this case. So let me just go to that. And here's where I'll clone that repo. So I refresh this. That's my clone repo. So far I've really done nothing special. I just created a sample Hugging Face repo, cloned it locally, and these are all the files. Now we can always review Docker files, but we don't need to. Again, as I said, this is all templated. Although I will point out that this will look slightly different compared to the Voila Docker file that we saw. That's because Streamlit has some different configuration which Docker must respect, and that's the reason that this looks slightly different than the one that we saw earlier. But something that we are the most interested in doing right now is opening src/streamlitapp.py and editing this code. We are no longer interested in what they have shown, what they did on their in the demo app. We are instead interested in deploying our own app and say, this is the app that we built, widgets demo. So I'll just copy this script and come back here to Streamlit app. This is their template. And simply edit this out. I just overrode all of that with what we have already defined. Something that I will verify before I push these changes back is that my requirements.txt it has all the things that I need. And obviously don't need alter, but I'll let it stay right now that there's no harm. And if I come back here, there's date time, which is available out of the box. I need pandas and numpy. This does have pandas, although typically always installs numpy, but we'll just have it there nevertheless. And that's it. If I go in there, it will show that I've modified a couple of files. add these, commit these with a message. And finally push this back to the repo. And if I come back here, you'll see that it's already doing a new build. It received my push changes. It's using that Docker file along with my code script in order to deploy a new version, and that's what we're seeing here. In a few moments, we'll have our app code deployed instead of this template that they have. So similar approach to Voila, just a little different and a little easier, I would say. And the only reason behind that is because Hugging Face Spaces has a template defined, a predefined template for Streamlit that we just cloned and modified. So that makes things a lot more easier than defining your own Docker file and building things from scratch. All right, there we have it. Perfect. All the interactions are, looks like it's respecting all of those interactions as well. Awesome. I realize we rushed through Streamlit, but any questions? A few of you were familiar with Streamlit, so we haven't, we weren't planning to look at any advanced Streamlit applications either. But hopefully, just by way of seeing how Streamlit apps are written and defined, you have a better feeling for the benefits that Streamlit brings over something like Voila or Jupyter Notebooks, where it's much smaller code, much more compact, and you don't have to worry a lot about arranging your outputs or inputs in specific components. It's just you can there's a way that you can add multiple tabs and panels in Streamlit as well. You can have multi-page applications and authentication and a lot more fancy things. But if you're interested in keeping things simple, this is a great way of just deploying something really quick. All right. Let's see. So that's Streamlit. Before we move on to Gradio, and we'll try spending about 15 minutes on Gradio as well. Again, it's something that I want you all to be aware of. It's a really nice web application framework. I will remind you though that in the beginning of the tutorial, around 8:30, 9ish, we all built an app store. And as you're deploying these applications, I would encourage you to go back to that app store. It's inside or wherever you made it. For me, it's in App Gallery. Maybe for some of you, it showed up as my portfolio or something. That's probably because of an earlier version of the Git repo. But for me, it's in there. And as you're deploying these applications, just go to projects.yaml and add the URL for these apps. So, for example, for Hugging Face, you could either add this URL as it is, or a better way of getting this URL would be to click on these three dots on the top right, and there's an option to embed this space, which will give you the source of this iframe. And if I open that just looks like I've deployed Streamlit in this case natively, and it hides away all the Hugging Face abstractions around my iframe. Just as you're deploying, modify the title, description, add the URL right there. The images is optional. You can, if you have the patience to take a screenshot or use some online image that you have, use it. But if not, you could let that be. And all that you'll have to do is, for Quarto, you'll just have to render it locally, and then just use Quarto pub or Quarto space publish, Quarto -pub to redeploy to the initial app store that we created in the morning. Okay, so let me zip through all of this. Right. Um, let's spend about 15 minutes on Gradio, and then we'll take a quick break before moving on to Fast Dash. And then deploy is the final um, aspect that I wanted to discuss was about deployment in general, but we have been looking at that in bits and pieces all along. So hopefully that will go a little quicker. Okay, so we have already seen Voila, which helps us deploy Jupyter notebooks. We have seen Streamlit, which is really innovative in the way that it uses declarative programming, and you can just write stuff the way that you define you know variables in a Python script, where for debugging purposes, I simply use print statements most of the times, and Streamlit takes that approach to programming. You can just write your Python code, and Streamlit basically takes care of deploying it without you having to modify a few things and change a whole bunch of configurations with your app. Gradio takes this a step further, and let's jump into a very simple Gradio application. And again, there are three steps in which you build a web app with Gradio. Obviously, you start with the main app code. It's all function based. So as long as you have a function defined or a set of functions defined for your app interaction, that's usually sufficient. So you define your function, then you create the interface. In this case, they call it demo, which is a Gradio app. The name for this variable could really be anything, but we define it with gr.interface. And its main purpose is to accept three key arguments. The first is the function that you want to deploy as a web app. The second is the inputs that you want to use for each of the inputs to the Python function. And the third is the way in which you want to display the outputs. Simple. So we have the function, we have the inputs, we have the outputs. Now this will look similar to widgets.interact method that we used with Jupyter widgets a little while ago as well. And that's because it is. In that case, we used widgets.interact. The first variable was the function that we want to deploy as a web app. The second input was the list, or instead of defining inputs, we defined, well, each of our arguments to widgets.interact was each of the arguments to the Python function itself. So in this case, would have been name equals to widgets.text input and so on. But in this case, we can just simply use the keyword argument inputs and give it a list of all different components that we want to use for each of the inputs to the Python function. Outputs work the same way. We can give some option arguments like title and description. And the moment that I run this, let me import this. And we have an app. That is it. So I can just type in my name, Kedar in this case, hit submit, and that's the output. This was a simple text to text like app. So we were able to deploy this pretty quickly, and here's the result. Now, another interesting thing that you may have noticed is when we do a launch, and there's an option argument share equals true. I can disable this and it will work just fine. It's deployed to my port 7861 right now. But no one else can see this. But what's cool about Gradio is that the moment that I add share equals true as one of the arguments inside demo.launch, or in my interface.launch method, it gives me a public URL that I can now share with anyone else. And the only thing that I had to do was write a few lines of code in my Jupyter notebook, and I suddenly have a link that I can share with anyone on the web. Now these are short-lived. These don't persist. It says that this link expires in 1 week, and for additional deployment, we can either use Hugging Face Spaces, or looks like I don't know if we can upgrade to a higher enterprise version. Go ahead.
Forgive me if I could just get this answer from the docs, but
Yeah.
it looks
Mhm. It did. It did. Yes. Yeah, and you're absolutely right. And not just that. In fact, even the choice of components. We did not explicitly state anywhere that name has to be a string only, or we did not explicitly set the component. And that's an inbuilt abstraction where it understands that when we say inputs is text, it translates internally to an input component that allows us to input text. Exactly, like an input text box. But when the outputs is set to text, now we no longer have the ability to enter any text in there. That's because now that's an output text box. So it has all of these abstractions set inside it that just to make sure that as users we don't have to worry about changing any of these things beyond the ones that we care about. Exactly. Exactly. That's right. Now, instead of text, I could have always just given the exact gradio component here instead of the string text. That would have resulted in the same thing, but it's just easier for me to remember that text is text instead of widgets dot text input, as in the case of Jupyter Notebook, for example. And you're right, it did make some selections, some assumptions for us, like clear, submit, and flag. Nowhere in the code did we specify that we explicitly wanted these things. And also, it gave a two-panel layout where all the inputs go on the left and the outputs go on the right, and that's a bunch of decisions made for us on our behalf. But the good thing is we can always change these things to the extent that it's necessary. For simple apps, would I always change these? Maybe, but if I'm deploying this to people, 20 plus people, 50 plus people, then I'd most certainly want this app to look a certain way. Maybe I want the all the inputs at the top, stuff like that, like we have in all BI dashboards, and all the inputs, all the outputs are arranged below it. And all of that's configurable. We can do that. But by default, you're right, made a few assumptions for us and got us off to a quick start. Right, so that's a simple way, text in, text out. Similarly, obviously we can have multiple input and output components as well. It's a simple calculator function that we have defined. Um, Operation determines what operation we want to perform on num1 and num2, which is just numbers. If operation is add, it will add the numbers. If it's subtract, subtract, it will subtract the numbers, and so on. And notice here that we have three inputs in this case and not just one input as we had in the earlier case. And we could have in this case, so when we're defining the interface, obviously the first argument is the function itself, which is calculator. And in the drop down, we could have had only text, for example, which would have required us to add, the keyword add or the keyword subtract explicitly in that text box. But that's not ideal at all. And so instead of using a string as a component, now we can obviously always use one from many of the inbuilt widgets as well, or the inbuilt input components as well. In this case, we choose to use gr.dropdown, which is a dropdown component from Gradio. These are the options that we want, and this is the label which gets shown at the top of the app, top of the component. Similarly, we have a gr.number as well, which allows us to input numbers. This is for the first number, and this is for the second one. So three inputs representing three in function inputs themselves, and the output is just one. It's in all cases I'm just returning the value, which is either a number, or in this case it's just some text. And so the output is always just one. And I believe if we don't select any of add, subtract, multiply, or divide, which isn't possible because we have done a fair bit of defensive programming by adding drop down options, this app will just error out. But that won't happen in this case. And the output is just number. Had it been a string, that still worked. But then we have the title and its description. So if I run this, that's the app. We can have add to 45, something like that. And it gives us the result. Subtract gives us the result, and so on. But again, a few assumptions that the app made on our behalf. We're still following the two-panel layout. Inputs on the left, all the outputs get shown to the right. And another thing to note is that these inputs just keep on inputs and outputs, both component panes, only keep on stacking. So if I had 10 inputs, all of them would show up in a single column on the left. If I had 20 outputs, all of them would show in a single column on the right. And again, that's configurable. We can change it all, but it works out for our case, given the simplicity that this offers us. Again, when we're deploying a new app, the principle that this follows is that focus on the thing that matters, which is defining your Python function, defining your logic, your models, your algorithm, and then just by defining a few additional lines, just by writing a few additional lines and choosing a few components and some other basic configurations that you want, the app handles the rest, including few of the decisions, and that's the result. And then we have a shareable link right there as well. Now we can always deploy this on Hugging Face spaces, but for now, if any of you are running this notebook, maybe you could just grab one of these links and add it to the App Store, or maybe modify the function a little bit based on your data set, add a few figures and charts. And here's just an example with the Penguins data set that I have, which basically does that. It has two inputs, and I guess only two outputs. So one is a chart, matplotlib in this case, and a pandas data frame. That's how they are rendered. And the inputs are straightforward in this case, but the outputs output components are a little different than the one that we have seen before. We have the gr.plot, which shows matplotlib plots, and gr.dataframe, which displays pandas data frames, just for convenience. That's something that they have. And they have a list of many different features, or many different components that we can use. Here are just some of the most common ones that I've listed. We typically use text, numbers, and sliders, and options, and booleans, and uploading images, and file uploads. And compared to that, the choice of the output components is fairly limited. We typically only show text or images or plots and tables, and not much beyond that. Okay, so that's Gradio. Any questions? We will not look at deploying Gradio apps on Hugging Face spaces. That's because we already have a link that we can share. If you just said share equals to true. And if you're walking along, just feel free to take that link, put it in the Quarto App Store, and redeploy it so that it reflects there. Right, so let's take a quick break. I know that it's been a while. And after we get back from the break, we'll look at Fast Dash, which is something that I intentionally saved for the end. And we'll look at how Fast Dash makes even more decisions for us compared to Gradio. And for example, here's a simple app which all of you must have run at the beginning. In Fast Dash, we use the input and output type hints a little innovatively, in that, for example, this is just a simple Python function that, all of us define. But simply by adding a decorator to this function, FastDash is able to read everything about the function. It reads the function title. It reads the input and output variable names. In this case, input text, output text. It reads the type hints. It knows that input text is supposed to be a string. Output text is supposed to be a string as well. All the string processing can happen within these lines of code. And the moment it runs this, it's deployed to 8080. And there we have that. We can give it some input and get it back. So we'll use this concept of being able to inspect a function and be able to read the input and output type hints a little innovatively, and we'll also look at how to arrange output components and build some advanced applications with streaming. And if you're working with large language models, then there are a few things that we can do with this as well. So let's take a quick break. Let's reconvene at 11:20, and then we'll go through this, quickly look at um, how to use Google Cloud for deployment, which is my personal favorite way of deploying. Um, and then we'll take any questions if there are any. All right, see you in 10 minutes. All right, it's time to resume. Um, Before we dive into fast dash again, just wanted to point out that we were having a conversation a few minutes ago outside about how to go about deployment in enterprise situations and inside companies, and you know, not, most of the places where we work, we typically don't make most of the things that we do open source. So obviously, deploying to Hugging Face spaces as a public repo is out of the question. Deploying to Google Cloud, as we'll see in a little bit, in a public domain URL is out of the question. And I do that a lot. Where I work, we do not make public most of the things that we deploy internally. So I just wanted to mention that, although Hugging Face Spaces and Google Cloud will, which we'll see in a little bit, it abstracts away many of the Dockerizing steps that we typically execute when it comes to deployment. The concept remains the same. We still use Docker to make an image from our app code, but instead of pushing something to Hugging Face Spaces or doing a gcloud run deploy command locally, we SSH into a remote server, say an Azure virtual machine or AWS EC2 instance or something like that, or even on-prem device for that matter. We SSH into it and then use a Docker run command to deploy the Docker image that we are building. So that's the only difference between deploying to Hugging Face spaces versus deploying a Docker container on an enterprise scale or an enterprise infrastructure where things cannot be made public. So thanks for bringing it up. Right. So fast dash. Just let me preface it by reminding you all that this is a library that I built, and so although feels good when I share it with other people, and I'm proud of what I've built here. Um, this is not something that has hundreds of stars or thousands of stars. This is certainly not something that many other people are using, and that's a huge community behind it. So I want you to all to keep in mind as we review this. Um, Let me know what you think about this overall concept and mindset of deploying web applications, if it gels well with how you're used to deploying applications. One thing that I do want you to take away, well, besides how this works, is also how this can be reused in other ways. The principles, although they remain the same, um, maybe this is applicable to a different situation. Maybe this is applicable to a Streamlit like situation or a Gradio like situation, and not just Plotly Dash, which is the one that it's based on right now. But my principle when I, or a set of principles when I started working on Fast Dash was one, I wanted to get from idea to prototype really fast, faster than even Gradio. And all of these tools, they certainly have a some learning curve, and that's true about Fast Dash as well. But I wanted that to be as minimal as possible. And with Fast Dash, for some simple applications like text to text, image to image, image to text, charts, selections to charts and graphics, there have been cases where I've been able to use this in order to deploy an application. Obviously, once I had the Python code in a matter of minutes. And so I do believe in this principle, but I do believe that there's a lot of feedback that needs to come in before something like this, becomes popular, if it does. But I have no vested interest in this. This is something that I just do in my fun time. This is open source. I enjoy working on this, and obviously, because I have this, I use it at my company and encourage my friends to use this as well. But we already saw this, but the principle is this. So the Python functions that we typically deploy end up looking like this. So we have def something, name of the function. We have some inputs, and a good rule of thumb is to always type hint your functions. So in this case, input argument A is of type string, B is of type int, and the output that I'm expecting from this function are three things. One, the first output is a string as well, some text. The second output is a matplotlib figure, and the third output is an image, a PIL image. Be that a doc string followed by that, which this can vary. This can just be a single line, a few lines, or it can also have the arguments and the return types as well in it. We write everything about the function, and then we return the output of the function. Um, my effort with fast dash is to not have to do many other things besides writing the function in order to deploy this as a web app. And the way that I do that is by defining a decorator, fast dash, that reads the function title, it reads the input argument names, the output argument names, input types, output types, the doc strings, and makes a bunch of decisions for us. It chooses what components to use, it chooses the layout in which to show all of these outputs, um, and it obviously parses the function text and doc strings and everything about a function basically. And here's an example that we just saw. Let me disable all of the default arguments. And again, a simple function that I wrote, text to text, with input text as string and output as string as well. And this is a normal function. If I comment the fast dash element out, I can just reuse this. If I use this, it will just give me back what I gave it. But the moment that I add fast dash, I can obviously use this function as it is, as normal. But besides that, it also is deployed as an interactive web application. And this is by default accessible at port 8080. And yeah, as we saw, I can just input some text and it's shown to me as output. And all that we had to do was add a simple decorator to it. And it shows, the input component, the output component. It also put the doc string. Looks like my function. This one doesn't have a doc string, but it'll put stuff like that in the about key as well at the top right. It's a collapsible bar. But now we can quickly expand this to using multiple outputs. So here I have a function. I've requested. I've imported a few additional things. I have the request library. I have the matplotlib library imported. I also have PIL imported from Fastdash, but I could have just done import PIL separately as well. As this function, call it my function, takes two arguments. The first one is a string, other one is an integer, and it returns three things. It returns a string, some string. It returns a matplotlib figure, and it returns an image. And this image is static, not that we're generating that image. It's just we're just fetching the Fastdash logo from where it's hosted online, and that's exactly what we're seeing here. Text is always the same; it's output just for demo, and matplotlib figure is always static in this case as well. But the moment that I add a Fastdash decorator to this and run this, that's what I see. So I have the input text for my first input. I have the integer input now, so I cannot add any text in there. So I can only add integers there incremental in steps of one. And the moment that I hit submit, I see the output. So the text which was static is the output. Matplotlib figure is shown here, and the image that we wanted to render is shown here as well. We can take this a step further. So this Fastdash decorator can be given a few different arguments. We'll not go through all of them right now, but maybe one thing that we're interested in is not seeing the app deployed locally inline in Jupyter Notebook, and I can just do mode external, and it will just deploy the same thing, but to an 8080 endpoint now, or 8080 port by default in this case. Now, when I shared this with people in the beginning, they said that, hey, we also want to be able to arrange the output components in an interactive way, in a way that doesn't require us to write a whole bunch of code and define, output layouts and stuff like that. So I saw inspiration from Matplotlib. I don't know if you've ever used Matplotlib's Mosaic input, where you can just literally you can define ASCII like art using letters. You can use A, B, C, D and arrange a string. And that alone is enough for Matplotlib to decide how the subplot layout should be. So use the same concepts here, and say for the three inputs that we had, we wanted this layout, just hypothetically. We wanted the first two output elements to be shown in a row at the top, and the third output to be shown to take basically all the available horizontal space at the bottom. And we can simply do that by using this string. So when we define A, B, and C, C, what we are saying is that A is my first output component, B is my second, and C is my third output component. But I want you to arrange it in a way such that A takes the almost the top left, B takes the top right, and the entirety of the second row should be taken by component C or whatever the output is for component C. So we define that mosaic this way and just specify that in our in the fast dash function arguments as well. And the moment that I run this, now we have that. Maybe I've defined it slightly differently in this case. This. Oh yes, yes. Thank you. Yeah, right there. Not AC, but CC in this case. Thanks. So if I run this, then that's what we get. And so if I hit submit, that's basically the same function. But what I had earlier was AB and AC, which means that the first component will be the first column, and then the second at the top right, and the third the bottom right. And that's what this is. And, works the same way. And we can specify the input and output components in a few different ways, and all controlled by type hints. So I mentioned that we can use Python native data types like string and float, PLT figure, and other data types, pd.data frame and pil.image and stuff like that. You can also use some built-in components exactly the way that Gradio does as well. There's a text component, there's a chat component, which is really interesting. Let's see that down in this notebook. There's a graph component for Plotly charts. There's a table component for Matplotlib figures. But also more interestingly, I've also added support for using Dash native components. If you've used Plotly Dash before, this will look familiar. DCC.dropdown is a very popular Dash component for a dropdown. TMC.table is another popular component to show a pandas data frame. So 3 ways in which we can define the input and output components. And an example of each. One is, this is just an example function, datetime example, where the input type end is of type date from datetime, and it renders the app. If I import datetime, it renders a date selection component. If I have, if the input type if specifies Boolean with a default value, something false in this case, then it renders a checkbox, which is, if checked, it returns correct as defined by the rules here, and if not, it just returns wrong. And there are ways in which we can also play around with having input text as well as drop-down selections. Like in this case. In this case, the input is of type string, and the default value is just A, string A. And if you do that, it'll just put the default value there, but it'll still be a text box, as just like the one that we defined earlier. But if we change this slightly now to still using the input type string, the type int string, but the default value to a list, what we're saying is this is of type string, but I want to be able to select from only these options, A, B, and C in this case. So you just select A and B and C and so on, and it will just display. Similarly, both the input and the output type can be list. So the type int is list and the default value is list as well. All that we're saying in this case is, hey, my input can be a list, which means that now I can select multiple components and not just the one. And then submit, and then it runs the function and displays the output. There are built-in components as well. This is an upload image component that has been defined. Upload image is rendered in the upload image component, and the output is a simple image. So if I do that, and if I have click to upload image, and if I have some image there, this is just the one that I used for this tutorial, and then basically can handle images as well. and pandas data frames as well. Maybe I'll just run through this real quick. Uh, I just returned a sample pandas data frame, and I had to specify the output data type, but as long as I did that, it was able to render the uh, data frame into a nice table. And then there's the chat component where, unlike some of the components that we've looked at, the chat component expects a dictionary. It's a dictionary with two keys. The first key has to be query, which is the question from the user, and the second key has to be response, which is a response from whoever is responding, an AI agent or whatever. In this case, it's a static response from Groot. So if I say hi, and it will still render that as a chat component where input text input on the bottom or the top right, and followed by the response, and this can continue forever. That's the point, and each of these individual components is rendered through a dictionary, as we discussed. This is the query key, and this is the response key. But yeah, just by something like this, we can have a chat-like application, obviously with the correct logic and not this, but it's as simple as that to deploy this. In fact, I don't know if you guys noticed, but I built something similar with using the same code. I don't know if this is still working. I just deployed a simple LangChain application based on the description that I wrote for this tutorial. And is this about? It wasn't working as of this morning because of some rate limits, but yeah, it seems like it is working now. But yeah, it's basically using the same code, similar code rather, and I can just pull it up real quick. And I was able to build this in a matter of minutes, and that's all the code that it took to build that. So there's some LangChain LLM code that I found online from their tutorial. But as far as the app code is concerned, I just had to define this function, define the correct inputs and outputs, and use few update like helper methods so I could stream text and not display it in chunk. But basically, what you're seeing there is a result of just these almost 40 lines of code, no more than that. And then Docker file and everything else that we've already seen. So I could just deploy this to Google Cloud eventually. Okay, and yeah, some as I mentioned, we can also use Dash components for input and output. And this is a chip component that Dash has. I don't know the exact use cases for using a chip, but password, sure, it is a password, and just print something. But yeah, point being, we can use inbuilt Dash components as well in place of these type ends in order to use them for input and output. Okay, and a few advanced examples. I'll share these notebooks across so that you know what's happening. But I guess maybe I can just run through one of these real quick. So here, if my question doesn't end with a question mark, I just raise an exception just for demo. So if I type something, don't end it with a question mark, and the moment I submit, you'll see that it's a error notification, just some feature for debugging purposes, and it's streaming as well, as we saw in the LLM application a while ago that uses updates. Yeah, so that's fast dash. And again, just as a reminder, the couple of principles that I used in there was, one, it shouldn't have to be very difficult for us to go from idea to prototype, and this is my effort in that direction. All that you need to do is focus on writing your own Python function. That's really all it should take for you to quickly deploy something, have something spun up, and share with your team real quick. That's the purpose here. And the second principle that I use for that is, when you think of a web application, it's all really a single Python function. If it isn't, it can all be written in the form of a single Python function. And that's what we leverage in order to do something like this. It's highly abstracted, but we have a way of defining something, an abstraction such as this, that inspects a Python function and makes some decisions for our behalf, so that we don't have to be deliberate about making those decisions. And that allows us to go from to the prototype phase really quickly and efficiently. That's fast dash. We're a little low on time, so I had a nice exercise down here, but I'll share. You already have these notebooks, so feel free to play with it and let me know what you think. There's a it's an open source repo, obviously, which you can find here. TK-7 fast dash. There's also a documentation that goes with it where you can find some additional examples of using RAG-like approaches with LLMs and mapping and um, you know other examples that I've written over the past few months. Some user guide on what how to alter the properties of the function if you're interested in changing themes and um, rearranging the layout and stuff like that. That's you can do a bunch of customizations because it's based on Dash, and Dash is awesome. It allows us to do a bunch of things, but it's highly abstracted, and that does mean that you lose some of the control that you would have otherwise preferred. Right. So that's what I had with Fast Dash. There's one thing that I wanted to discuss before we wrap up, which is my favorite way of deploying applications, which is using Google Cloud. So maybe we spend 5-ish minutes doing that, and then we can open it for questions and start wrapping up. If you're interested in learning more about Google Cloud, or if you have other ideas of maybe some tools that I miss that you personally prefer and like and find are much more convenient than those we discussed today, let's definitely speak. All right, but before I let you go, let me show you how I deploy my apps to Google Cloud. You must have already gone through the steps of setting up Google Cloud CLI. So I won't show how those things work. I will show though that the Google Cloud service that I use for deployments is Google Cloud Run, which is this. It allows us to deploy apps serverless. What that means is whenever someone's not using our apps, they're basically sleeping, they're down, which means that if I click on one of these apps, let's say this one's up, so which means that someone clicked on it over the past few minutes, an hour or something like that. But maybe for something like this, no one's visited this for a while, and so it was sleeping. The moment we clicked on it, the server's spinning up. It takes a few seconds for it to completely get spun up, but the way that helps me is I don't have to pay a whole lot of money to have these links live always. And there it is, and we can just select something, and this is again based on Fast Dash and works the same way as we saw. So Google Cloud Run, that's what I use. My entry point into deploying an app obviously is writing a function like the one that I've written here already. There's also a fast dash method that I've added. Let me zoom in a little bit. So if you have fast dash already installed, let me go into a different folder somewhere. Demo file exists. So one of the things that we discussed was that most of these app deployments are really templated. Once if you've done this once, you can do it 100 other times without relearning a bunch of things. And so I try to leverage that. And if you have Fast Dash pip installed already, you can create a new project with Fast Dash demo 2, something like that, or demo. And then it asks what port you want to use by default, or which port you want to use. I'll just use 8080 because that's the port that Google Cloud requires for deployment. So just hit enter, and all of my files are generated. So if I look into the demo folder, it has an app.py, it has a Docker file, and it has a requirements.txt. And do I see that here? Oh no, it's in a separate folder. Let me do this. Let me open VS Code in that folder so that we see what's happening. And these are some folders that I've set up locally, but more importantly, I have this demo 2, which is the one that we just set up. Let's go inside it. CD demo 2. Just open VS Code inside there. So we have that. And if you inspect this, real quick, this is some boilerplate fast dash code, right? Simply deploys simple text to text, and we should we should ideally replace this by our own function, our own type hints, and other components and other libraries that we're using. We also need to modify requirements.txt. So far, the demo boilerplate only uses fastdash and Junicorn for deployment. Those are the only two that I'm using right now. And Dockerfile, again, it's templated, it's pretty simplistic. Nothing fancy going on here, but we'll ignore this for now because we don't really need to change it. Now, here comes the more interesting part. Let me go inside my app folder, and you'll see that I have gcloud CLI already defined or already installed on my device. And as long as I have a Docker file and requirements.txt set up well, I simply do gcloud run deploy. We're deploying this application, the Docker file, to Google Cloud run. It asks for a few things. It says, hey, is this your source location? I said, yes, this is my source location. Is this what you want to call your service? I would say, no, I want to call my service demo SciPy. I'm not sure if dashes are allowed, but we'll see. What region do you want to deploy your application in? I usually just select one of the US West regions. Allow unauthenticated invocations, yes. And that's it. In a few minutes, my app will be on the internet, accessible to anyone, with the same interactions that we saw locally. But yeah, accessible through HTTPS. It takes a few minutes. It pushes my code there, builds a Docker file, deploys the container, and so on. This is Google Cloud, obviously, and we have allowed all unauthenticated visits to our app. But I imagine a similar scenario where I'm not sure if what degree of offerings Google Cloud Run has to enterprise customers. If we can have like private clouds and follow the same process or not. I haven't used Google Cloud at work ever, so I'm not familiar. I have deployed tens of different applications on Google Cloud, free for anyone to use. So this is the way that I prefer. It's fast, it's easy. You don't have to rely on Hugging Face spaces, terminating your apps, or changing some things in the backend that breaks your pipelines. Is something that you control. Although you have to add your own credit card, which is a drawback, but I guess there's nothing like free lunch. But yeah, that's how I do it. Okay, so we have about 10 minutes. I wanted to wrap up real quick, summarize everything that we have seen so far. For that, let's go back here. Okay. So we saw that, work not shown is really work lost. And there is a real value in sharing your ideas, deploying your applications. But at the same time, you don't want to spend a whole lot of time and effort in deploying simple ideas if they are only going to be used by 10 to 50 people. And it's important to fail fast as you go through the process of building these applications and eventually productionizing your ideas. There are 3 steps that we typically take to building a web application. We always start with the why. That's probably the most important question to ask. Then we come to the what, which is all the KPIs and metrics and what insights we want people to read from our apps. And then we come to the how. We saw a how in a lot more depth. We saw a few tools. We looked at Voila, we looked at Streamlit, Gradio, we looked at FastDash, we looked at a couple of different ways in which we can deploy our applications. We looked at Hugging Face Spaces, we looked at Google Cloud, and we also, through the process of that, we saw that there are really 4 steps in deploying an application once you have the Python code locally running on your device. After you have it running locally, step 2 is you Dockerize it, step 3, version control, and step 4, deployment to a server. Now, version control server can be internal enterprise deployments as well. They don't have to be cloud publicly accessible. But more importantly, we saw that it's all templated. Once you know that Gradio is the tool for you, there's a specific template that we follow in order to deploy Gradio applications to wherever. If you decide that Streamlit is the way for you, there's always a template that we follow to deploy and host Streamlit apps anywhere we want. And that's really what I want you to take away today. You know, going from ideas to prototype doesn't have to be difficult. And I must have said this twice or thrice already, but this is a little difficult to grasp. I struggle a lot, still do, with Docker and deploying. But once you've done it twice and thrice, the fourth time is 10 times as easier as the first one. Um, and yeah, so that's what I had. I'm here for the week. So if you have any feedback, any questions, any thoughts, if you want to build a new application together, feel free to approach. Thank you.